Welcome to today's deep dive into one of the most specialized members of the bear family, the polar bear. From the frozen coastlines of the Arctic to the drifting sea ice of the far north, polar bears are icons of survival in one of the planet's harshest environments. But this species is more than just a symbol of the cold. Polar bears are a remarkable evolutionary offshoot, a lineage shaped by ice, isolation, and the pursuit of a very specific lifestyle. And their story is tied to that of their closest relative, the brown bear. In fact, polar bears are so recently diverged that they can still interbreed with brown bears, producing fertile offspring. And yet, they've gone on to evolve profound changes in physiology, behavior, and even metabolism, adapting to a life almost entirely dependent on sea ice and seals. Today, we'll be exploring what sets polar bears apart from other bears, how they evolved, how they live, and what challenges they face in a rapidly warming world. If you'd like to learn more, check out the document in the description with research papers and image credits. Last week, we looked at the American black bear and the brown bear, two of the most widespread and adaptable members of the genus Ursus. Both species have diversified across vast territories, evolving unique traits to match their environments. But they're not alone. Ursus maritimus, the polar bear, is the third living member of the so-called core Ursus group, and genetically, it's actually closest to the brown bear. In fact, brown bears and polar bears diverged remarkably recently in evolutionary terms. Genetic and fossil evidence suggests they split within the last 400,000 to 500,000 years, during the height of the Pleistocene glaciations. That makes them not only the youngest bear species, but one of the youngest large carnivores still alive today. So, how did one lineage of omnivorous forest-dwelling bears give rise to the Arctic's top predator? What changes were needed to survive an environment with no trees, no hibernation dens, and only one major prey animal? To answer those questions, we need to explore both what polar bears share with their closest relatives and what makes them so uniquely adapted to life on the ice. Life in the Arctic posed an entirely different set of challenges. Unlike the forested or mountainous landscapes of their ancestors, polar bears found themselves in a stark, windswept world of ice and sea. Here, herbivory was no longer an option, and even scavenging required vast, mobile ranges across ever-changing sea ice. Surviving in such an environment meant becoming a full-time predator and adapting to open water and frigid temperatures. Fossil evidence of early polar bears is sparse, but one notable specimen, a large ulnar unearthed from gravel deposits in southern England near London, has been tentatively assigned to a possible extinct subspecies, Ursus maritimus tyrannus. Dated to around 70,000 years ago, this robust bone may represent a transitional form between brown and polar bears, or simply an unusually large early individual. Either way, it underscores how recent and rapid the transition was from omnivorous generalist to Arctic specialist. What's especially striking is how quickly natural selection reshaped their physiology. Within a few 100,000 years, polar bears developed longer necks, narrower skulls, more streamlined bodies, and modified teeth suited to a diet of seal blubber and meat. Their fur and foot pads evolved for insulation and traction on ice, while their kidneys, liver, and cardiovascular systems adapted to handle extreme fat intake and prolonged fasting. Even their reproductive timing became fine-tuned to the Arctic's seasonal rhythms. And yet, despite these differences, polar bears remain genetically close enough to brown bears to interbreed. In fact, hybrid Pisley or Growler bears have been confirmed both in captivity and in the wild, a reflection of their relatively recent divergence. But their ecological roles are now vastly different. One adapted for forest and omnivory, the other a specialized predator of the frozen sea. The polar bear, Ursus maritimus, is the largest bear species alive today, and the most carnivorous. Native to the Arctic Circle, it inhabits the circumpolar regions of Canada, Greenland, Norway, Russia, and Alaska. Unlike most other bears, it is not a terrestrial animal in the strictest sense. Polar bears are considered marine mammals, spending much of their life on sea ice rather than solid land. This unique lifestyle is reflected in their name. Maritimus means of the sea, a reference to the polar bear's dependence on marine environments for both survival and movement. They are expert swimmers, capable of covering vast distances in open water, and they rely heavily on drifting sea ice to hunt, rest, and reproduce. As apex predators of the Arctic ecosystem, polar bears are uniquely tied to the presence of ice and access to marine mammals, especially seals. Their survival hinges on a fragile and rapidly changing environment, making them not only icons of the North, but potent symbols of climate vulnerability. Surviving in the high Arctic demands more than size or strength. It requires an entire suite of specialized adaptations. And the polar bear is a masterclass in fine-tuning. Their most obvious feature is their thick, creamy white fur, ideal for camouflage against snow and ice. But this fur isn't just for disguise. Each hair is hollow and translucent, helping trap warmth and direct sunlight toward the bear's skin. As a result, polar bears actually aren't white. They only appear that way because their fur scatters visible light. Beneath that fur lies a dense layer of insulating underwool, and under that a thick layer of subcutaneous fat, sometimes over 10 centimeters or 4 inches deep, that provides buoyancy, energy storage, and critical insulation. It might seem surprising, but beneath their famous white coats, polar bears have black skin. This is a critical feature that absorbs and retains the maximum amount of heat from the scarce Arctic sunlight. This clever combination helps polar bears stay warm in freezing temperatures, enabling them to survive in one of the most extreme climates on Earth. Remarkably, this insulation is so effective that polar bears are nearly invisible under thermal imaging or infrared goggles. Their dense fur and thick layer of fat trap almost all of their body heat, making it very difficult for predators or prey to detect their presence by heat signature alone. Polar bears are the largest land carnivores alive today. Adult males typically weigh between 400 to 600 kilograms, that's 800 to 1300 pounds. And in peak condition, they can exceed 1,000 kilograms or 2,200 pounds. Females are significantly smaller, especially when not pregnant. Their long, stocky bodies and relatively small heads help conserve heat, while short, rounded ears and stubby tails minimize exposed surface area, a textbook example of cold climate adaptations for retaining warmth. Their feet are particularly well adapted for Arctic conditions. Massive forepaws, up to 30 centimeters or 11 inches across, help distribute their weight as they walk across thin sea ice. The soles are covered in small papillae or friction bumps, which improve grip, and their long, curved claws provide traction and are used for holding slippery prey. The paws are also partially webbed, helping to propel them through the water when swimming. Unlike most bears, polar bears have slightly elongated necks and narrow elongated skulls, adaptations for reaching into sealed breathing holes and dragging prey out of the water. Their sharp canine teeth and powerful jaw muscles are designed not for grinding vegetation, but for piercing and tearing meat and blubber. Even their metabolism is adapted for extremes. In the summer, when sea ice retreats and hunting becomes more difficult, polar bears can enter a walking hibernation, reducing their activity and conserving energy without entering full dormancy. And pregnant females then in snowdrifts for the winter, entering a torpor state similar to hibernation while giving birth and nursing cubs. Note that neither of these examples are true hibernation. Polar bears are the only species of Ursus not to hibernate, but they achieve a similar goal of conserving energy to make it through tougher times. Although, conversely for polar bears, this tends to be the summer season, as opposed to brown or black bears that famously hibernate for the winter. In short, nearly every aspect of the polar bear's body is tailored for a life on ice, in water, and in some of the harshest climates on Earth. But even these remarkable adaptations have their limits, especially when the environment itself begins to change. Polar bears are the most carnivorous of all living bears. While other Ursus species are omnivores to varying degrees, the polar bear is a true hypercarnivore. Its diet is composed almost entirely of meat and primarily one source: seals. Their preferred prey are ringed and bearded seals, both abundant in Arctic waters. Polar bears hunt for them by waiting at breathing holes or breaking into snow dens where pups are born. This method, known as still hunting, relies on immense patience and an exceptional sense of smell. Polar bears can detect seal dens buried under a meter of snow or smell a seal breathing hole from nearly a kilometer away. Hunting on sea ice is central to their survival. Seals surface through breathing holes or haul themselves out onto the ice to rest, and polar bears depend on this frozen platform to catch them. But this dependence comes with a cost. When the ice melts in summer, hunting becomes far more difficult. Some bears fast during the ice-free months, relying on fat reserves built up in the spring. Others turn to scavenging carcasses or foraging opportunistically, but these alternatives are rarely sufficient to sustain them long term. Unlike brown bears, which get energy from plant matter, polar bears cannot survive without a high-fat diet. Blubber from seals is their primary energy source. It fuels their enormous size, supports their insulating fat layer, and provides the calories needed for survival in sub-zero conditions. A single adult seal can yield tens of thousands of calories, but successful hunts are infrequent, and polar bears often go days without food. This feast or famine lifestyle has shaped every aspect of their biology. Their liver is adapted to process extreme amounts of vitamin A from seal livers, a quantity that would be toxic to many other mammals. Their metabolism is specialized for fat digestion and storage, with energy-conserving mechanisms to endure long fasting periods. Even their gait is affected by hunting. Polar bears are built for energy efficiency on flat terrain, but are relatively slow and awkward over land. They are powerful swimmers, however, able to paddle for hours between flows or hunt seals in open water. Some have been recorded swimming over 100 kilometers or 60 miles without rest, a feat unmatched by any other bear. But as sea ice retreats and becomes less predictable, polar bears are forced to swim farther and fast for longer, a growing challenge for a species so finely tuned to its icy domain. Polar bears are among the most solitary of all bears. Outside of the breeding season and the bond between mothers and cubs, they typically live and hunt alone. Even in areas with abundant food, like whale carcasses or dense seal populations, they tend to keep their distance, avoiding direct competition when possible. When encounters do occur, they usually resolve through posturing or withdrawal, but serious fights can break out, particularly between adult males. Unlike many terrestrial carnivores, polar bears are not territorial. Their home ranges can span hundreds of thousands of square kilometers, shaped more by the shifting sea ice than by fixed boundaries. These ranges often overlap, and individuals may cover vast distances in search of food or mates. In summer, when sea ice retreats, polar bears face an annual challenge. Some remain on the ice edge, following its movement northward. Others are stranded on land where food is scarce. During this time, they enter their walking hibernation state, reducing their activity and slowing their metabolism to conserve energy until the ice returns. On land, they dig shallow daybeds in snowbanks or seaweed piles, resting for long periods in the relative safety of coastal areas. Young polar bears are highly playful, especially when traveling with their mothers. Playfighting and roughhousing aren't just for fun. They help build the strength, coordination, and social awareness needed for survival. Adults, too, can be curious and inventive, showing problem-solving abilities when investigating new objects or scavenging from human settlements. While not especially vocal, polar bears do use sounds to communicate, particularly between mothers and cubs. These include huffs, growls, and low-pitched chuffs. But in the vast openness of their environments, much of their communication relies on scent trails, body language, and behavior rather than calls or marking. In times of extreme scarcity, polar bears may exhibit more desperate behaviors. Cannibalism has been recorded, typically involving adult males killing cubs, or in rare cases attacking other adults. These events are uncommon, but serve as a stark reminder of the pressures these animals face in such a harsh and variable environment. Polar bear reproduction is shaped by the unique demands of life in the Arctic, where timing, fat reserves, and environmental conditions all play a crucial role. Like their closest relatives, polar bears rely on a strategy called delayed implementation. After mating in spring, typically between April and June, the fertilized egg doesn't immediately begin developing. Instead, it remains in a suspended state until later in the year, giving the female time to build up fat reserves and assess whether conditions are suitable for pregnancy. If the female is underweight or in poor condition, the embryo may not implant at all, a natural safeguard against reproducing in an unfavorable year. But if conditions are right, implementation takes place in autumn, and the female seeks out a den site, usually on land, digging into snowdrifts or soft ground, although some populations den on sea ice if necessary. During the denning period, which lasts several months, the pregnant female enters a state similar to hibernation, though true hibernation is rare in polar bears outside of pregnancy. Her body temperature drops slightly and her metabolism slows, allowing her to survive the winter without eating or drinking. It's during this time, typically between November and January, that she gives birth, usually to 1 to 2 cubs, though litters of 3 have occasionally been recorded. The cubs are born blind, hairless, and completely dependent on their mother. Their weight is 600 to 700 grams, or around 1.5 pounds at birth, about the size of a guinea pig, and spend the next 2 to 3 months nursing in the den while the mother continues to fast. During this time, she provides warmth and rich milk, fueling the cubs' rapid growth. In early spring, the family finally emerges. By then, the cubs have grown considerably, but are still small and vulnerable. The mother leads them back to the sea ice, where she resumes hunting and begins to teach them survival skills, including how to stalk seals, avoid danger, and navigate the frozen landscape. Rearing cubs is a major energetic investment. A mother may lose up to half her body weight during the denning period, and the success of her offspring depends heavily on the availability of sea ice and prey once they emerge. Cubs typically stay with their mother for about 2.5 years, learning vital behaviours before setting out on their own. In a landscape as unforgiving as the Arctic, every stage of polar bear reproduction, from mating to weaning, is finely tuned to the rhythms of ice, hunger, and time. And as the climate warms, disrupting those rhythms, the entire reproductive strategy may be placed under increasing strain. The polar bear is one of the most iconic victims of climate change, a symbol of an ecosystem in rapid flux, and for good reason. Unlike other Ursa species, polar bears are almost entirely dependent on sea ice for survival. It's their hunting platform, their travel corridor, and, for pregnant females, often the gateway to denning areas. But Arctic sea ice is vanishing. In just a few decades, summer ice cover has declined dramatically, and what remains is thinner and more fractured. This forces polar bears to swim longer distances, fast for extended periods, and in some cases abandon traditional hunting grounds altogether. While some individuals have been observed foraging on land, eating birds, eggs, or vegetation, these foods are nutritionally inadequate for a predator evolved to hunt on energy-rich seals. Land-based foraging may delay starvation, but it can't replace the high-fat diet polar bears need to survive and reproduce. And as ice-free seasons grow longer, even the best ice-adapted individuals face a narrowing window for successful hunting. Climate change also disrupts timing. Delayed freezing can prevent pregnant females from reaching denning areas in time, and earlier melt can strand mothers and cubs before they've regained lost fat. These pressures compound existing risks, such as pollution, oil exploration, and potential conflicts with humans, as bears spend more time ashore. As of now, polar bears are classified as vulnerable by the IUCN. There are estimated to be around 20,000 to 25,000 individuals globally, divided into 19 subpopulations. Some of these groups are relatively stable, while others, particularly in the southern and western parts of their range, are in steep decline. Conservation efforts are complicated by the vast remote geography of the Arctic and the transboundary nature of polar bear populations. International agreements, like the 1973 Agreement on the Conservation of Polar Bears, have laid important foundations. But as warming accelerates, habitat loss is outpacing regulation. Ultimately, the fate of polar bears is not just about protecting a species, it's about confronting the broader collapse of a once predictable Arctic ecosystem. And in many ways, they are the ice's canary in the coal mine, a visible, charismatic reminder of what's at stake. Polar bears have long loomed large in the human imagination, as predators, as spirits, and increasingly as ambassadors for a warming world. In the traditional cultures of the Inuit and other Arctic peoples, polar bears are respected and often revered. Known as Nanuk or Nanuk, the bear is viewed as both a formidable hunter and a spiritual being. Stories portray it as wise, powerful, and deeply connected to human survival. A figure of awe, but also kinship. Hunting practices historically followed strict rules, balancing need with ritual and respect. In Norse and Siberian folklore too, The polar bear appears as a mysterious creature of the north, sometimes feared, sometimes honoured. Its white coat and solitary nature have made it a frequent symbol of the supernatural, the sacred, or the unknowable. Today, the relationship is more complex. In places like Churchill, Canada, or Svalbard, Norway, polar bears and humans live in cautious proximity. Churchill is often called the polar bear capital of the world. Each autumn, hundreds of bears gather near town while waiting for Hudson Bay to freeze, leading to regular and sometimes tense interactions. Strict safety protocols are in place, including patrols and a polar bear jail for problem individuals. Cars are often left unlocked as well, to provide escape for anyone caught in a polar bear attack. In Svalbard, polar bears outnumber people. Visitors are required by law to carry a firearm or flare gun outside settlements for protection, and encounters, while rare, do happen. But Svalbard has also become a hub for polar bear tourism and Arctic research, a frontier where the line between wilderness and civilization is actively negotiated. And of course, beyond the Arctic, the polar bear has become a global symbol, used by environmental organizations, artists, and activists to represent the climate crisis. From soft toys to protest banners, its image often carries emotional weight, a solitary figure adrift on melting ice. But behind this symbolism lies a real animal, powerful, vulnerable, and uniquely adapted to one of the harshest environments on Earth. Understanding its biology, history, and challenges gives us more than just empathy. It gives us insight into how evolution works, how ecosystems change, and how our own choices ripple outwards. I hope you enjoyed this deep dive into the world of polar bears. From the sea ice of Hudson Bay to the remote islands of the Arctic Ocean, these animals are more than just icons of the North. They're highly specialized survivors, shaped by isolation, climate, and evolutionary pressure. Where other bears show adaptability across diverse habitats, the polar bear tells a different story, one of extreme specialization and fragility. Its biology, behavior, and conservation status reminds us how quickly things can change in a shifting world. So if this video sparked your curiosity, don't let it stop here. Share it, talk about it, and keep learning. There's still so much to uncover about the world's rare and remarkable species. And the more we understand, the better chance we have of protecting them. If there's another fascinating species you'd like to learn more about, let me know in the comments below. I am tempted to continue my journey through bears too, so if you'd like to hear about other species, whether the remaining species in Ursinae, or the unique journeys of the spectacled bear or giant panda, then let me know that as well. But thanks for watching, and I hope to see you next time.